In this experiment, our aim is to observe the action of iron, copper, zinc and magnesium on the solutions of copper sulfate, zinc sulfate, aluminium sulfate and silver nitrate and arrange them in the order of reactivity based on the results observed. Materials required: small pieces of iron, copper, zinc, magnesium, aqueous solution of copper sulfate, zinc sulfate, aluminium sulfate and silver nitrate. Procedure: to test the reactivity of iron in the solution of copper sulfate, zinc sulfate and aluminium sulfate, take small pieces of iron and put them into the beakers containing copper sulfate, zinc sulfate and aluminium sulfate solutions. Leave the beakers undisturbed for 1 day. After a day, the color of copper sulfate solution turns from blue to light green and red-brown particles of copper settle at the bottom of the beaker. This indicates that iron is more reactive than copper, as Fe2+ ions displace Cu2+ ions from copper sulfate solution. In the other two cases, there is no change observed. This indicates that iron is less reactive than the other two metals, aluminium and zinc, so it cannot displace these metals from their salt solutions. To test the reactivity of copper in solutions of silver nitrate, aluminium sulfate and zinc sulfate, add pieces of copper into the silver nitrate, aluminium sulfate and zinc sulfate solutions. After a day, the colorless silver nitrate solution changes to blue-colored copper nitrate solution and silver particles settle down at the bottom of the beaker. Here, copper is more reactive than silver, so it displaces silver from silver nitrate solution. In the other two cases, since copper is less reactive than aluminium and zinc, there are no changes observed in their salt solutions. To test the reactivity of zinc in the solutions of copper sulfate, aluminium sulfate and silver nitrate, take small pieces of zinc and add them in the beakers containing these salt solutions. After a day, we can observe that red-brown particles of copper settle down at the bottom of the copper sulfate solution. This indicates that zinc is more reactive than copper and it displaces copper from the copper sulfate solution to form zinc sulfate. In the case of silver nitrate, since zinc is more reactive than silver, it displaces silver from silver nitrate solution and particles of silver settle down at the bottom of the beaker. But in the case of aluminium sulfate, no change is observed as zinc is less reactive than aluminium. So zinc cannot displace aluminium from aluminium sulfate solution. To test the reactivity of magnesium in the solutions of copper sulfate, silver nitrate and zinc sulfate, add small pieces of magnesium into the beakers containing these solutions and leave them undisturbed for 1 day. After a day, we can observe that copper, zinc and silver particles settle down at the bottom of the beaker containing the respective solutions. This indicates that magnesium is more reactive than copper, zinc and silver. So it displaces copper from copper sulfate solution, zinc from zinc sulfate solution and silver from silver nitrate solution. From these reactions, we can infer that iron displaces copper, zinc displaces copper and silver, and magnesium displaces zinc, copper and silver. So magnesium is the most reactive metal and copper is the least reactive metal.